What do copper wire, talcum powder, jewelry, and table salt have in common? All these things are made from minerals. So what exactly are minerals? What's the difference between a rock and a mineral? What are some of the characteristics of minerals? And how do you go about identifying them? During the next few minutes, we're going to answer these questions and others as we explore the fascinating topic of minerals. The mineral turquoise in this piece of jewelry and the mineral gypsum used to make sheetrock are just two examples of the more than 3,000 known minerals. Surprisingly, though, over 90% of the rocks in the Earth's crust are comprised of only 20 minerals. These minerals are generally called rock-forming minerals. Chances are the rocks you see around your neighborhood are made up of two or more of these common rock-forming minerals. For example, this rock, called granite, contains three main minerals: feldspar, quartz, and black mica, or biotite. So what exactly is a mineral? A mineral is a naturally occurring solid that has a definite chemical makeup and crystal shape. Phew, that's a mouthful. So let's break this definition down into smaller pieces. To start with, minerals are found in nature. Minerals are also solids with a definite volume and shape, and minerals have a crystal structure. A crystal is made of particles which form a pattern that repeats itself over and over. Sometimes a crystal pattern is quite obvious, as is the case with this quartz crystal. But sometimes special microscopes are needed to observe crystal shapes. Another characteristic of minerals is that they have a definite chemical makeup, which means they contain specific combinations of elements. You can think of an element as a chemically pure substance, like iron. Most minerals are made up of two or more elements. Quartz, for example, is made up of the elements silicon and oxygen. As we mentioned, there are thousands of different kinds of minerals. Geologists often classify them in groups to make them easier to study. A common way to group minerals is based on their chemical makeup. For example, minerals are often placed into two main groups: silicate minerals and non-silicate minerals. Silicon, the element in silicate minerals, is very common in rocks. Quartz and feldspar are examples of silicate minerals. Non-silicate minerals do not contain silicon. Sulfur, calcite, and salt are examples of non-silicates. Sometimes scientists group minerals as metallic or non-metallic. Galena and copper are examples of metallic minerals, whereas halite and calcite are non-metallic minerals. Because there are so many different kinds of minerals, it isn't always easy to tell them apart. You compare. Which of these two minerals is gold? The one on the left is gold. The one on the right looks like gold, but is called pyrite, or fool's gold. Even though these minerals look similar, they have characteristics which make them different from one another. Each mineral has its own specific properties that can be used to identify it. A property is a characteristic of a mineral. One of the easiest mineral properties to notice is the color of a mineral's outer surface. The problem with color, however, is that the same mineral can come in several different colors. And in some cases, different minerals may have the same color, as we just saw with pyrite and gold. Sometimes a mineral streak is helpful in identifying it. Streak is the color of a mineral's powder when rubbed against a piece of porcelain. Notice how this mineral has a shiny metallic appearance, but this mineral has a dull appearance. This property is referred to as luster. Luster is the way the surface of a mineral reflects light. There are many ways that minerals reflect light. Metallic, non-metallic, waxy, and earthy are some of the ways we describe a mineral's luster. You observe. Was this mineral scratched with a fingernail or with a steel knife? Your fingernail can't scratch it, but a steel knife can. This softer mineral, however, called talc, can easily be scratched with a fingernail. Different minerals have varying degrees of hardness. To determine the hardness of minerals, scientists use a scale called Mohs hardness scale. On this scale, talc is the softest mineral at 1, and diamond is the hardest at 10. Between these two extremes are other minerals with progressing degrees of hardness. Different types of minerals tend to break in different ways as well. Cleavage is the tendency of a mineral to break along flat surfaces. Notice how this piece of halite and this piece of biotite break along flat planes. You observe. Describe how this quartz breaks. Quartz breaks unevenly. Fracture is the tendency of minerals to break along irregular or curved surfaces. Another way minerals differ is in the types of crystal structures that they form. There are several different basic crystal shapes. In some cases, minerals can be identified by other properties, such as density, taste, and odor, to name just a few. Minerals form in a variety of ways. Many minerals are formed from molten rock beneath or above Earth's surface. When molten rock cools, mineral crystals are formed. Mica, feldspar, magnetite, and quartz are formed when molten rock cools. Changes in temperature, pressure, or chemical makeup inside Earth can also alter rocks to form different minerals. Garnet, graphite, talc, and magnetite are formed this way. Sometimes minerals form in solutions of mineral-rich water. These formations were formed in Mono Lake, California, when the lake was much deeper. Minerals such as sulfur and iron are often formed in geothermal pools. Sometimes, when mineral-rich water evaporates, it leaves behind mineral crystals. These salt crystals in Death Valley were formed when salt-rich water evaporated. These are just a few examples of how minerals form. During the past few minutes, we've explored some of the fascinating characteristics of minerals. We saw that minerals are very important substances which make up rocks. Minerals are naturally occurring, inorganic solids that have a definite crystal shape and a definite chemical composition. We discussed how geologists sometimes classify minerals as silicates or non-silicates. Minerals possess many different properties, which can be used to identify them. We briefly investigated the properties of color, streak, and luster. We also explored the properties of hardness and the use of Mohs hardness scale. Some of the other properties used in identifying minerals were demonstrated, including cleavage, fracture, and crystal shape. So, the next time you use something made from minerals, or notice a piece of jewelry, think about some of the things we've just discussed. You might just think about minerals a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. Have a definite chemical makeup and crystal shape. Number 2. A is a characteristic of a mineral. Number 3. This mineral has a metallic. Number 4. Is the tendency of minerals to break along flat surfaces. And number 5. When rock cools, mineral crystals form.